Hello students, welcome back. It's me Dikendra semester. Today I am here with the remaining part of pressure of class 10 science. In previous video we discussed about law of flotation. I think you have understood about this. Law of flotation means weight of floating object is equals to weight of displaced liquid. We have proved experimentally. Today we are going to discuss about the remaining part of the pressure relation. And today we are going to discuss atmospheric pressure, standard atmospheric pressure, and some reasonable questions related to the atmospheric pressure. After that, mercury barometer, torricellian vacuum, some applications of atmospheric pressure like syringe, air pump, and operated water pump, etc. Let's start the topics. Atmospheric pressure. We have discussed already about the pressure and liquid pressure. Pressure, we have defined force acting normally over unit surface area. Liquid pressure, pressure given by the liquid on the surface of containing vessel. Like this way we have defined. Anyway, weight of the object, force of the object creates the pressure on the surface area. Similarly, air is matter, thick layer of air that surrounds the earth is atmosphere. Our earth is surrounded by the thick layer of air, about more than 1,000 kilometers from its surface. This thick layer of the air is called atmosphere. And this air also is matter. Matter has its own weight, and this weight of the air adjusts the pressure. So, atmospheric pressure means pressure given by the atmospheric air on the unit surface of area of the earth surface. That is called atmospheric pressure. Pressure given by the atmospheric air on the unit surface area of the earth due to its weight. That is called atmospheric pressure. Okay, atmospheric pressure. Atmospheric pressure at the sea level is maximum. Atmospheric pressure at the sea level is maximum. This maximum atmospheric pressure at the sea level is called standard atmospheric pressure. Standard atmospheric pressure, and its value, standard atmospheric pressure value is 760 mm of Hg or 10 to the power 5 pascals. Okay, so standard atmospheric pressure is a maximum pressure which we find or which we can find on the sea level. That is called standard atmospheric pressure, and its value is 760 mm of Hg or 10 to the power 5 pascal. Standard atmospheric pressure. When the altitude increases, when the height increases from the earth's surface, atmospheric pressure will be same, less or more. What do you think? Atmospheric pressure decreases with increase in altitude. Atmospheric pressure decreases with increase in its altitude. Why? Already we have defined air adjusts the pressure on the unit surface area of the earth due to its weight. We know, you have read in the first lesson, fourth lesson. Gravity, earth gravity holds the atmosphere, holds the air, and its effect, effect of the force of gravity decreases with the increase in altitude. So when the height increases, density of air, thickness of air decreases gradually from the earth's surface. Okay, due to the gravity or effect of gravity, when the altitude increases, force of gravity decreases. That's why less amount of air holds at the higher level than that of the lower level. That's why atmospheric pressure decreases when the altitude increases. Because of this reason, air-filled balloon bursts at maximum height of the atmosphere. Because of this reason, when the altitude increases, atmospheric pressure decreases. Because of this reason, an air-filled balloon, when it reaches the maximum height, it bursts. Why? Hydrogen-filled balloon. children use this ear-filled balloon or hydrogen-filled balloon. Generally in the festival time, yeah, they blow in the ear. Such type of balloon bursts at the maximum height. Why? While filling the ear, while filling the hydrogen gas on the earth's surface, pressure of air or gas inside the balloon and pressure of atmospheric air outside of the balloon are equal. That's why it can sustain, it remains in the proper condition. But when the same balloon reaches to the maximum height, when the same balloon reaches to the maximum height, atmospheric pressure gradually decreases. Atmospheric pressure gradually decreases, but pressure of air inside the balloon, pressure of the gas inside the balloon is constant or remains constant. So, inside of the balloon, pressure of the air, pressure of the gas inside the balloon remains constant, but atmospheric pressure decreases. So, when it reaches to the maximum height, atmospheric pressure outside of the balloon will be less than that of the air pressure inside the balloon. So high pressure of the air inside of the balloon push it outward, because of which balloon burst. Yeah, I think you have seen astronomers use the special type of suit while traveling to the space. Why? To maintain the pressure, body pressure. Okay, to maintain the body pressure. If they do not use the such type of special suit, then body may blast like a bomb, because in the space there is no air and only the body pressure, blood pressure creates the outward pressure, and there is no external pressure from outside, because of which body may blast. So they use the special type of suit. In 1 meter square area of the earth, 1 lakh Pascal pressure adjusts continuously by the atmosphere, but we never feel. Why? We don't feel atmospheric pressure. Why? Because inside our body there is blood and other fluid, or you can say liquid inside the cell, like the cytoplasm, protoplasm, etc. So this type of fluid, this blood adjusts the pressure continuously, and the pressure created by this body fluid and pressure exerted by the atmosphere are nearly equal, because of which they act in two opposite directions, so cancel each other. That's why we don't feel atmospheric pressure. Okay, this blood or body fluid exerts the pressure outside, and atmospheric pressure exerts inward to our body side, and they are nearly equal. So as the two equal forces in opposite direction, they cancel each other. That's why we never feel the atmospheric pressure. So, do you know which instrument is used to measure the atmospheric pressure? To measure the atmospheric pressure, we use a special type of instrument that is called barometer. Okay, barometer. Barometer is a device which is used to measure the atmospheric pressure. It can measure the altitude also, height of the place. Because when the height increases, pressure decreases. They are related to each other. So, device which is used to measure the atmospheric pressure, that is called barometer. Generally we use mercury barometer and aneroid barometer. Aneroid is modern portable barometer. And here we are going to discuss about the mercury barometer. Okay, mercury barometer. Mercury barometer, to construct, to make mercury barometer, first of all we have to use 1 meter long glass tube. 1 meter long glass tube. Okay, this is 1 meter long glass tube. This 1 meter long glass tube completely filled with the mercury is inverted over a mercury trough. A trough filled with the mercury. Okay, so here is mercury trough also. So it is also completely filled with the mercury. This is mercury. Okay, mercury. This is mercury trough, you can say. Mercury trough. So first of all, we have to take 1 meter long glass tube. We should fill the mercury here. After that, we should take another mercury trough and we have to invert over it. While inverting this 1 meter long mercury tube, some space is left at the top. Some space is left at the top. Why? Because while pouring the mercury into the glass tube, atmospheric air exerts the pressure. But while inverting it, mercury exerts the pressure downward. Pressure exerted by the mercury is more than atmospheric air. That's why molecules contract each other. So some space remains at the top. It was discovered by the scientist Torricelli. That's why with his name, or by his name, it is called Torricellian vacuum. Torricellian vacuum. So Torricellian vacuum means space which is left at the top of mercury barometer. Space which is left at the top of mercury barometer, that is called Torricellian vacuum. And Torricellian vacuum is different than real vacuum. In real vacuum there will be nothing, but in Torricellian vacuum there is mercury vapor. Okay, there is a mercury vapor in the Torricellian vacuum. That's why it is different than real vacuum. So to measure the atmospheric pressure, we have to take this mercury barometer up to the higher altitude or lower altitude, and to calculate the pressure, here is one gravity scale parallel to this 1 meter long glass tube. It is a fixed gravity scale. While taking this mercury barometer to the higher altitude, level of mercury inside the tube decreases. Okay, when the altitude increases, atmospheric pressure decreases. So when we take this mercury barometer to the higher altitude, level of mercury inside this mercury barometer decreases. Why? Because outer atmospheric pressure is less, inner pressure of the mercury will be more. That's why more liquid flows from high pressure to low pressure. So mercury starts to outflows from the tube. That's why level decreases and measure the less pressure. Similarly, when you take this mercury barometer to the higher altitude, lower altitude, at that time there is more pressure. High pressure of the atmosphere push the mercury downward, because of which some mercury inserted from the tube, base of the tube, and the level of mercury increases in the tube and measures the high pressure. So level of mercury increases while taking the barometer to the lower altitude, and decreases while taking to the higher altitude due to change in atmospheric pressure. Okay, after this, by using the atmospheric pressure, we have made, or scientists have made, or we use different types of devices which makes our life easier, like to fill the ink into the pen, to suck the juice by using the straw pipe. That is possible due to the atmospheric pressure. Similarly, here we are going to discuss about the other applications like syringe, ear pump, and hand operated water pump. You know, syringe is a medical instrument. Syringe is a medical instrument. It is used to inject the medicine to the patient's body or to pull the blood from the patient's body. How it is possible to pull the medicine, to pull the blood in the syringe? It is possible because of the atmospheric pressure. Let's say syringe. It's a syringe. So, syringe. Syringe consists mainly of 3 parts. It is called cylinder. It's a piston. And this part is called nozzle. And this one is needle. Needle. So, before pulling the medicine, before pulling the blood into the syringe, first of all, we press the piston inward. We press the piston inward. Why? To let out the air which is inside the syringe, to let out this air, first of all, we press this piston inward. After that, we insert this needle into the patient's body or into the medicine. Then we start to pull the piston. When we pull the piston outward, at that time, in this part, partial vacuum is created because this air is already drawn out. Air is already drawn out. So while pulling, some space remains here. Some space remains here. In this place, partial vacuum is created. Partial vacuum means there is less pressure. And compared to this, medicine will have the high pressure. Blood will have the high pressure. And you know, liquid always flows from high pressure to low pressure. Because of which, after that, while pulling the piston outward, medicine easily enter into the chains, which can be injected to the patient's body at the time of need. This is the syringe construction. Similarly, ear pump. You know, ear pump is a device based on atmospheric pressure and used to fill the ear into the ball, into the tire, etc. Yeah, ear pump. We have seen to fill the ear into the bicycle tire, in the vehicle's tire, similarly in the ball, etc. Yeah, ear pump. That also works on the basis of atmospheric pressure. Yeah, here is ear pump. This is ear pump. Modern types of ear pump it is. Yeah, ear pump. So, in this ear pump, it consists of the three parts. This one is piston with handle. This part is piston with handle. This one is cylinder, we see, cylinder. And here is a nozzle which is connected to the objects like a ball, bicycle, tire, etc. So, you can see, here is, this one is called washer or valve, we say valve, okay. This one is valve. Here is a hollow cylinder, okay. This one is a valve. So, when we pull the handle or piston upward, so this is pressure. While pulling the handle upward, this gap between this nozzle and then this handle or piston increases. When the gap increases, there will be the more volume. In the more volume, there is a less pressure. Okay, less pressure. So here is more area or more volume and less pressure will be there. When there is a less pressure, this washer from here, this washer will be contracted. Washer will be contracted, valve will be contracted. Because of which air of the atmosphere inserted from the ear. Okay, here. From there is some gap. From this gap, air inserted into the cylinder. And when we press this handle downward, this gap decreases, area decreases. Area decreases means pressure increases. Yeah, pressure increases. Because of the high pressure, this air passes through the nozzle and it is connected to the bicycle tube or ball. So this air pushes or opens the valve present in the bicycle tube or this ball. I think you have seen or you have heard bell to in bicycle. Actually, that is not bell to, valve to. Okay, valve to. Valve 1 is here. I have shown you. Here is a valve 1. And valve 2 present at the bicycle tube, at the bladder of ball. That is the valve 2, not bell 2. So, this valve 2 open due to the high pressure and air passes into the tire. But when it is pulled out, when it is taken out, due to the high pressure of the ball, it is again pushed outward, because of which valve is still closed. Because valve shows unidirection. Valve gives unidirection. Every type of valve, not only this type of valve, every type of valve checks the backflow. Checks the backflow, like a door. Yeah, like a door. When we push the door from one side, it opens. And from the other side, it closes. Similarly, here also, in valve also, when it is pushed from one side, it opens, can enter into the ball, enter into the tube. But while pushing from the inner side, itself it closed, can't come out. That's why this air remains in the tube, remains in the bladder continuously. So when there is the more area, with the less pressure at that time, this washer or valve present in it contracted and air enter into the cylinder. While pressing it, area decreases, pressure will be high. High pressure of the air passes through the nozzle and enter into the bicycle tube, similarly bladder, etc., which makes easy or light to fill the air into the tube. Another one is hand-operated water pump, especially in Tarai region. Okay, especially in Tarai region, we use hand-operated water pump. Underground water can be lifted by using the water pump. So, this water pump also works on the basis of atmospheric pressure. Like let's say here is a figure. You can see, I think you have seen this type of tap in your home also. This is the figure of hand-operated water pump. In exam may ask one question from here. Remember. Okay, simple figure of the hand water pump. It's a pipe which is inserted into the underground water level. Yeah, it's a cylinder or barrel also you can say. Yeah, this is called piston. This is handle. It's a spout, okay, and this one is piston valve. We say washer. Yeah, if you have such type of tap, such type of water pump in your home, then in our local language we say this is a washer. In the market we can buy washer. That is the piston valve. And here at the bottom side, at the base of the cylinder, here is another foot valve. We say foot valve. That is called in local language lever. Yeah, lever. In local language, lever. That is a foot valve actually. And washer at the base of piston. That is called piston valve. So, how does it work? How can it is possible to lift the underground water by using hand water pump? It is very important. Actually, it works in two steps. So, it's a handle, piston, spout, cylinder, piston valve, and foot valve. It works on the basis of atmospheric pressure, principle of atmospheric pressure. How does it help to draw the underground water? How can it lift underground water? We have to discuss about this. Its function is divided into two parts. We say upstroke and downstroke. Two steps, okay? Upstroke and downstroke. So, it works in two different mechanisms. We say upstroke and downstroke. Upstroke means that is related to the movement of piston, okay? Movement of piston, upstroke. Movement of piston upward movement of piston upward is called upstroke. But for the upstroke, we have to press the handle downward. When the handle is pushed downward, piston is lifted upward. Yeah. When the handle is pressed downward, piston is lifted upward. This movement of piston upward is called upstroke. Okay, upstroke. When the piston moves upward, gap between piston valve and foot valve increase or decrease. What do you think? When this piston valve moves upward, the gap between piston valve and foot valve increase or decrease? Surely increase. When the area increases, pressure decreases. Yeah, pressure decreases. So inside the cylinder there will be the less pressure. Compared to this, pressure of underground water will be high. And you know, liquid always goes from high pressure to low pressure. That's why this high pressure of underground water pushes the foot valve. High pressure of underground water pushes the foot valve, and water is collected in the cylinder. Water is collected in the cylinder. This is called upstroke process. Another step one is a downstroke. Downstroke means movement of piston downward. Okay, movement of piston downward. For the movement of piston downward, we have to lift the handle upward. When the handle is lifted upward, piston moves downward. Okay, when the handle is lifted upward, piston moves downward. So this process is called downstroke. Movement of piston downward is called downstroke. When the piston moves downward, gap between foot valve and piston valve will be less or more. When this piston valve or piston moves downward, then gap between these two valves will be less or more. Surely less. When the area is less, then pressure will be high, more pressure. So at that time, pressure will be more in the cylinder due to the high pressure. Due to the high pressure, foot valve pressed down, that is closed. Yeah, foot valve closed, and high pressure of water push the piston valve upward. Piston valve upward. That's why piston valve open, foot valve closed, and piston valve open. Due to which this water collected in the cylinder lifted upward. Due to which this water collected in the cylinder lifted upward through the piston valve. Once again, when the piston moves downward, gap between two valves decreases. When the area is less, pressure will be more. Here will be more pressure. Because of the more pressure, foot valve pressed down, that means closed, and high pressure of water push the piston valve from the downside, it opens. Yeah, it opens. And then high pressure of the water, this passes through the piston valve and lifted upward, which can come out or which comes out from the spout. In this way, we can describe the function of hand water pump in upstroke and downstroke process. This is very important difference between function, etc. Upstroke, downstroke, movement of piston upward, upstroke, movement of piston downward, downstroke. Yeah, in upstroke, foot valve open, piston valve close. In downstroke, foot valve close, piston valve open. Difference between. That is very important for your exam purpose also. Okay, my dear student, we have finished the pressure lesson. How do you feel? Yeah, don't forget to repeat the video. Look, repeat the video time and again. You can understand the matter. Yeah, so it is very fruitful for you. Yeah, if you have any query, any questions, then you can comment it. Thank you.